In Section 2.6, we will learn how to draw a scatter plot and find a prediction equation, and also solve problems using prediction equations. When we collect data in real-life situations, the relationship is not always going to form a straight line when graphed. However, the graph may approximate a linear relationship. When this is the case, a best fit line can be drawn, and a prediction equation can be determined. We determine our prediction equation similar to the way we determine an equation for a line when we have 2 points already known. Before we go over actually determining our prediction equation, let's go through the steps we will need to work through when we are given real-life data in order to plot our points and determine the line of best fit, and then lastly find our actual prediction equation. When we are given a set of data, the first thing we need to do before plotting points is determine and label our axes. It is easiest if you assign the smaller values or smaller numbers to the x-axis and the larger numbers to the y-axis. The second thing we do is actually plot our point values. The third thing we do is actually draw a line of best fit. We can then establish the slope of the line and start to write our slope-intercept form of the equation. We will then be able to plug in one of our x and y coordinates to find and solve for the y-intercept. Once we have our equation, we can then use this equation to predict future outcomes. So let's go through each of these steps in a real-life example. Each of 7 executives oversees a varied number of salespersons. Below is a chart with the number of salespersons and the total sales for 1 month for each executive. Starting with step 1, let's determine and label our axes. I chose the smaller value, the number of salespersons, for the x-axis and labeled in increments of 10 starting with 5. I chose the larger number of sales, and went up by hundreds starting with 100 up to 700 because the highest number of sales we have is 699. Then I followed step 2 and plotted the points. We just want approximate point values, so we can just plot them according to our axes and see if we can determine if there is a line of best fit. The line drawn in brown would then be our estimated line of best fit, or step number 3. In step 4, we are going to find our estimated slope. We can do this by using 2 points and determining the slope by plugging them into the equation for slope. We end up determining that our estimated slope should be around 20. If we put 20 in to our y-intercept form of the equation, we get y equals 20x plus b, where b is our y-intercept. Our next step tells us to plug in a value for x and y to actually solve for the y-intercept of b. I chose to use the point 17 for x and 350 for y, and then I will solve to get b by itself. Now that I have determined that the y-intercept, or b, equals 10, I can plug that back into the slope-intercept form of our estimated equation for the approximate equation of the line of the values in our chart. So our equation for the line of best fit was y equals 20x plus 10. Now that we have an equation representing the data in our chart, we can use this information and the equation to predict different outcomes. So if I want to know if there are 30 sales people, then how many sales there will be, I'll just plug in 30 for our x because x was the amount of salespeople, and then I can solve for y, our number of sales. This tells us that if there are 30 salespeople, we can estimate that there will be around 610 sales. Please make sure you understand this example and how we can go through those 7 steps to plot points from given data, determine a line of best fit, and then determine and estimate our equation, which will then let us predict outcomes in the future. We will go through more examples in class, and you will have more problems assigned as homework. And as you can see, graph paper might be helpful. If you don't have some, I will have some for you to use in class.